How is algebra unreasonably effective for natural phenomena? Imagine a world where everything around us follows hidden rules that can be written down with simple symbols and equations. That's what algebra does. It's like a secret language that helps us understand how nature works. When you look at the way rivers flow or how plants grow, algebra can describe those patterns perfectly. Many natural systems follow specific relationships that can be written as equations with variables, which are symbols for unknowns or changing quantities. These equations help us predict what might happen next or how different parts of nature are connected. Starting with basic ideas, algebra helps explain proportional relationships. For example, if you double the amount of water flowing into a river, the flow rate changes proportionally. Algebra also helps us understand rates of change, like how fast a car accelerates or how quickly a population grows. It can show us balances in nature, such as how the amount of water entering and leaving a river stay equal over time. These simple algebraic formulas are the foundation for making models that predict natural behavior. Moving further, many natural patterns are fractals. Fractals are shapes that repeat at different sizes, like the branching of trees or the shape of mountain ridges. Algebraic formulas can generate fractals through iterative functions, which means applying the same rule over and over. This helps us see that these patterns are not random but follow specific mathematical rules. Understanding these rules helps explain why natural shapes look the way they do. Algebra also plays a big role in studying dynamical systems. These are models that show how things change over time. For example, weather patterns or the way a river meanders can be described with equations that depend on other variables. Sometimes small changes in initial conditions can lead to very different outcomes, a phenomenon called chaos. Algebra allows scientists to analyze these complex behaviors and make predictions about natural processes. For students working on their 12th grade academics, mastering algebra is essential. It helps solve real-world problems involving rates, proportions, and patterns in nature. Recognizing how algebraic equations connect to natural phenomena makes learning more meaningful. For example, the Fibonacci sequence and the golden ratio appear in plant arrangements and shells, linking abstract algebra to real-life examples. This understanding builds problem-solving skills and prepares students for future science and engineering studies. In short, algebra's power in explaining natural phenomena comes from its ability to express relationships and patterns mathematically. It helps us predict, analyze, and appreciate the order in the natural world. For students in their final year of high school, learning algebra is not just about passing exams. It opens the door to understanding how the universe operates through numbers and equations, making the world around us a little more understandable and fascinating.